So let's have a look at chemical properties. Ionic compounds form giant ionic lattices, lattice structures, which are held together by strong electrostatic forces that occur between the oppositely charged ions in ionic compounds. These electrostatic forces are called ionic bonds. So ionic compounds form giant ionic lattice structures which are held together by electrostatic forces. Just to recap that a bit more, which compounds are ionic lattice structures? So we're looking for ionic compounds when we're thinking about ionic lattice structures. So calcium carbonate is an example of an ionic compound. Magnesium chloride is another example. Barium iodide is another example. Now, the lattice structure of ionic compounds gives them some properties. So the first one is a high melting and boiling point. So to break ionic bonds, lots of energy is required to overcome the electrostatic forces that occur between the ions and the electrons in the lattice. Now, this is because compounds have a very high melting point and boiling point. They also can't conduct electricity when they're solid. Now, because when they're solid, the ions in the lattice are in a fixed position, and that means the charge can't flow through them, so electricity cannot be conducted within these giant ionic compounds. But they can conduct electricity when they're liquid or if they're in solution. So when they melt or if they're dissolved in water, the ions then are free to move around the lattice, and because of this, the charge can then flow and electricity can be conducted, but only when melted or dissolved in water. So when ionic compounds are melted or dissolved in water, the ions become free to move. And just to recap some of those properties of ionic compounds, they can't conduct electricity when solid. They can conduct electricity when melted. And the high melting and boiling points are created by the strong electrostatic forces between the ions. So for small covalent molecules, intermolecular forces are different depending on the different molecules. So the small covalent molecules are held together by strong intermolecular forces, and all that means is forces that are in between the molecules. And they're called covalent bonds. Lots of small covalent bonds can be held together by intermolecular forces, and these intermolecular forces are weak and easy to break, and that means small covalent molecules have low melting and boiling points, and they're often liquids or gases at room temperature. So to recap that, individual small molecules are held together by intramolecular bonds, and numerous small molecules can be held together by intramolecular bonds. Now remember, an intramolecular bond are just covalent bonds, and they're very strong. But an intermolecular bond is the forces between molecules, and they're very weak and easy to break. Small covalent molecules are held together by strong intramolecular covalent bonds. Remember, those are different intermolecular bonds which are weak. So, and also remember that ionic compounds form giant ionic lattices. And some of the properties of ionic compounds is they don't conduct electricity. They do conduct electricity when they're liquid. They do not conduct electricity when they're solid, and they've got high melting and boiling points. Now, if you've got small molecules, the molecules between, sorry, the forces between the atoms in the molecule are covalent bonds, the intramolecular bonds, and the forces that hold together different small molecules are the intramolecular bonds, or intramolecular forces. Why are covalent molecules liquids or gases at room temperature? So when small molecules melt or boil, it's the weak intermolecular forces that break. Since these intermolecular forces are weak and break easily, simple covalent molecules have very low melting and boiling points. Therefore, they exist as liquids and gases at room temperature.